Alright, so let's talk about a mini review because like last week all we talked about was review for the benchmark in Unit 4. We got away from Unit 5, right, which was quadratic functions. Okay? Someone tell me standard form. We need to work. Or quadratic function. Nope, that's formula. I just want function. What's it supposed to look like? Because a lot of the times you're going to have an equation or a function that's going to be mixed up. You might have to move some stuff. Oh, go ahead. Go, Aaron. Ax squared plus bx plus c equals 0. Okay? That's important. Always got to have a 0, okay? Always got to have a 0. Let's see. All right, now, after we talked about that, we talked about the quadratic formula, which a lot of you guys already knew. Okay? Someone raise your hand. Tell me what the quadratic formula was. Close.
B close to minus.
What kind of B? Just a B?
No, negative B.
Negative B.
Plus or minus square root of B squared minus 4A multiplied by 2 over 2A.
Over 2 what?
A.
Yep. Over 2A. Okay. Someone look at this and tell me what's really important about it. What do you always have to have in your answer? Okay, right.
Plus or minus.
Plus or minus, right? Why? Two answers. Going to have 2 answers. Okay. Always going to have 2 answers. What's up, Ben? What do you mean? What happens if it's not a 0? Always have a 0. Okay. Reason why? All right. Especially in factoring, everything's going to be set equal to 0 for the most part because you're going to use something called the zero product property. Okay. We'll talk about it in a second, but what that is, after I factor something out, I'll have a set of parentheses. I set everything equal to 0 and solve. Okay, that way I can find my zeros, my roots, things like that. Okay, so everything's always going to be set equal to 0. Okay, now, Coach Fitzpatrick. All right, if you're over there testing, head on back over. Okay. All right, now. So what we're going to talk about today is factoring. see. Lexi, hit that back button, please. All right, back. All right, you don't have to write this down. Okay, it says, recall that a factor is one of two or more numbers or expressions that when multiplied produce a given product. We can factor certain expressions by writing them as the product of factors. Okay, so one of the biggest reasons why we've talked about GCF, okay, because a lot of times that's the first step you always do when it says, okay, factor the following expression. Okay, I've got to find a GCF if there is one. Your first part of your thought process is I've got to find a GCF. Okay, I'm looking for a GCF. Now it says the zero product property states that if the product of two factors is zero, then at least one of the factors is zero. After setting a quadratic equation equal to zero, we can sometimes factor the quadratic expression and solve the equation by setting each factor equal to zero. You do need to write down the zero product property. Take a second, write this down, make sure you have it. Okay. While you're doing that, I'll have an example over here to put on the board. Okay. Now, for example, let's say we factor something out which we haven't really learned or talked about yet, and it looks something like, okay, x minus 2, x plus 2 equals 0. Okay? You're not done. Okay, you're not done yet. So, x minus 2, x plus 2. Zero product property says if I have something set equal to 0, I've got to set each parentheses equal to 0 and solve for x. So what's in my first parentheses? What's in my first parentheses? Someone tell me. X minus 2. I set it equal to 0. What's in my second parentheses? X plus 2. I set it equal to 0. Both these look like equations you can solve and have solved before? Yeah, right? So how do I get x by itself in this first one? X minus 2. Add 2 to both sides. So I've got x equals 2. Subtract 2 from both sides of this one. Those cancel out. X equals negative 2. So I got two answers, right? Try something out. See if you guys can see this. I'm just curious. Okay. Now, one of the big things, what does standard form for a quadratic equation look like again, or quadratic function? Ax squared plus bx plus c, what? Equals 0. Anytime you see something equals 0, okay, zero product property, I've got to set everything I have equal to 0 and solve. That's a zero product property. That is important. Something you'll use in this section almost every day. Right? Pate, stay with me, buddy. Alright, take another second. So, finish this up, we'll move on. Now, there is a cool method how you can check when we factor. Okay? There's a pretty neat method that you can use to check when we factor. And we'll talk about that. It's called the smiley face method. I'd say it's lame, easiest way ever to check to see if you're right after you factor a quadratic expression. Okay. Okay. I'll let you know what you got to write down. So the greatest common factor, GCF, is the largest factor that two or more terms share. Okay, we've talked about it. Write that bullet point down. The greatest common factor, or GCF, is the largest factor that two or more terms share. Okay? You should always check to see if the terms of an expression have a greatest common factor before attempting the factor further. Okay, like I talked about before, when we talked about factoring expression, the first thing you're always going to look at, does it have a GCF? That's the first thing I'm always going to ask myself. Is there something that it shares that I can take out? Alright, the value of a quadratic expression in the form ax squared plus bx plus c is called the leading coefficient. Okay, so anytime for the most part, what we're going to work on today is when your a equals 1. When you're just going to have x squared or a squared or b squared. Okay, nothing in front of the a right now. We'll get to something called bottoms up method once you do. Okay, David, stay with me, all right? You put your pencil down and write. Okay. Back to the leading coefficient or lead coefficient because it is the coefficient of the term with the highest power. Okay, leading coefficient in any kind of expression you ever see, we've already talked about standard form. Okay, that is what? What's standard form? When what equals 0? One more time. That's standard form of quadratic. I'm just looking for standard form of any polynomial. What? Anytime you've got, what happens if instead of a quadratic, I've got something that says like 4x cubed plus 5x to the fifth plus 6x. Is that in standard form? No, because what? Not in order. Highest degree, right, which is the highest exponent, the smallest exponent. Okay? That's important. The only thing you need is the greatest common factor in this slide. All right. So as a factor of trinomial with a leading coefficient of 1 in the form x squared plus b plus c, find two numbers d and e that have a product of c and a sum of b. Okay, I know that sounds confusing. I'll make it a lot easier in just a second. The factor form of the expression will always be x plus b, x plus c. So what this tells you right here, every time I'm factoring something out, your answer is always going to be in parentheses. First thing you can always do, look for GCF, and right under where it says factor, okay, Anthony, right? I can, put your name out. I can write two parentheses for my answer. I'm always going to have it, okay? Now it says, next slide, I've got a table that might help you out. But, okay, what I do want you to write down, over here. Go ahead and throw up an example for you. I've got x squared plus, let's see, 4x plus 4. Okay? Take a second, write that one down. Just take a second, write it down. That's all I want you to do. It says factor the following. And we're going to factor the following expression. That's what it means by factor. X squared plus 4x plus 4. Okay, first thing it says, find two numbers d and e that have a product of c. Okay, that's confusing, right? All right, does this have a GCF? Now listen, variables do come into play with the GCF. Okay, meaning, okay, well, every single one of these would have to have an x for it to have a greatest common factor. Does it? No. Okay. So it doesn't have a GCF. Now, what did I say your answer is always going to have? Parentheses. Parentheses. Okay. So the first thing I'm going to do, I'm going to write my two sets of parentheses. Okay. Now, what do you guys think would go right here and right here? X. Why do you think X? There's two of them. X squared means you got two X's. That's right. So I've got an X here, and I've got an X here. First thing, after I put my X's in here, I've got to figure out how to fill out those parentheses. So the number I'm always going to look at to start with is our constant. Now, what's our constant? 4. Why is it a constant again? Can someone tell me? It doesn't have a variable next to it. It's never going to change. It's always going to be 4. Okay? This is what I'm looking at first. Okay? So our first step, find the factors of 4. What times what can give me 4? 2 times 2 is what? And 2 times 2. Okay? Now, one of those, 1, 4, and 2 and 2, is going to go in those parentheses. I just don't know what it is yet. Okay? After I find the factors of my last term, my constant, okay, I want to figure out, and I'm looking at my middle term now, which is 4. Well, how can I combine 1 and 4 or 2 and 2 to get a positive 4. Okay? So the next part I'm looking at, how can I get my middle term? Okay, now in your parentheses, you're always going to add or you're always going to subtract. You're never going to multiply, not going to do anything else. Okay? So I'm looking at how on earth can I get my middle term with 1 and 4 or 2 and 2 with 4? How can I combine them somehow to get that? Is there any way I can combine 1 and 4 to get 4? Is there? What's 1 plus 4? Oh, that won't work. What's 1 minus 4? 3. Is that 4? No, so that doesn't work. What's 2 minus 2? 0. That's not 4. What's 2 plus 2?
4.
Oh, that works. Okay? So when I said 2 plus 2, were both those 2's positive or negative? Positive. Okay? So I'll say plus 2 plus 2. I just factored the expression. I'm done. Okay, that's it. Nope. I'm done. That's all I wanted. I wanted my answer in parentheses, and I wanted something inside the parentheses to finish it up. That's where we got x plus 2 and x plus 2. We're done. That's it. We factored the expression. There's nothing more we can do. Now, if it was set equal to 0, we'd have to use the zero product property and set each parentheses equal to 0. And that's the thing you've got to be careful with sometimes. Sometimes you'll just have an expression like this that's not set equal to 0, and you just got to factor. You don't have to do anything with setting each parentheses equal to 0. Other times, okay, it'll be set equal to 0, and then you'll have to use the zero product property and set each parentheses equal to 0 and solve for x, or whatever variable is in there. Okay? Now let's take a look at this table real quick. All right, just look. Okay. The last slide gave us a bunch of variables that represent different things. Okay, it gave us a B, a D, a C, and an E. Okay. What this table shows us, if my B and C are both positive, in parentheses I'm going to have both positives. If my term's up there, if it's a negative bx plus c, then I'll have a minus and a minus. If, in between, now when it says this, y'all, probably should have wrote this in before, but we're going back to our standard form for a quadratic. Ax squared plus bx plus c equals 0. All right, now it's just telling you the signs, okay? Because we're talking about factoring. Again, remember, everything is going to be what? In parentheses. It's either going to be minus or plus, 2 pluses, 2 negatives, whatever. So, for example, if I have 2 positives right by my B and right by my C, you guys see positive by the B, positive by the C. Well, then they're both going to be positive in the parentheses. Doesn't work for you. All right? Now, what if, for example, I had a minus and a plus? Both my terms would be what? Minus and a minus. Okay, what if I had a plus and a minus? Okay, now what that means, okay, and that's where it kind of gets a little bit confusing. Sometimes I might have a positive number in the middle, okay, and I'm trying to get a negative number on the outside. Well, how can I get a negative number on the outside? I'd have to multiply a positive number and a negative number together, right? Okay, well, if my middle term's a positive, it just means my middle or my larger term is going to have to be positive, okay? Larger term would have to be positive, okay? Now, if they're both negative, okay, it says opposite signs. The number with the larger absolute value is negative. So if both these signs are negative, well, what does that mean? That means, how can I get a negative number on the outside, multiply a positive and a negative, and how can I get a negative number here? My larger number would just have to be negative, because when I combine them, I need a negative number. And we'll go over plenty of examples to show this. Take a second, copy down that table. Okay? It'll be a good reference for a little bit for you. Now let's see if you guys can do something else when we're talking about GCS. Let's say I want you to find the GCF of 4x cubed y squared plus x squared y. While you're copying down the table, just find the GCF 4x cubed y squared plus x squared y. It's the first thing I'm going to do, okay? What are the factors of 4 in the first term, and what are the factors of what's right here? 1. Well, the GCF of 1 and 4 is going to be 1. Okay, you can write a 1 on the outside or you don't have to. Okay, I want to look at the x's. I want to look at the x's and the y's because it's what I'm going to take out. What do my x's share? They both have 1, right? Now, when it comes to greatest common factor, here's one way we can do it. How many x's are in the first term? 3, right? How many x's are in the second one? How many do they share? They have 5. You should have 2, right? So I can take an x squared out. What about my y's? This one has 2, this one has 1. To me, do they at least have in common? What's the most they have? Excuse me. 1, right? So I take 1 out. Now here's the tricky part. We're almost, you guys know the distributive property, right? It's in front of the parentheses, you got to multiply. Yep. Well, this is almost like reverse multiplication. Okay, reverse distributive property. Okay, now I'm just looking at how on earth, okay, because I still have x's and numbers left over that I didn't take out, and I still got to put it right here for the remaining. Did I do anything with my 4? No. I had 3 x's, I took 2 away. How many do I have left over? 1. I had 2 y's, I took 1 away. How many do I have? 1. I had 2 x's, I took 2 away. How many do I have? I had a y, I took 1 away. How many do I have? None. Okay, so here's the tricky part about this. Can I put 0 right here? Because if I distribute this back out, I've got to get this. And I know x squared, anything times 0 is 0. What times x squared y would give me x squared y? Anytime you multiply something by 1, you get itself. 1. Now check this out. What's x squared y times 4xy? Well, I get 4. X squared, remember I add exponents. X squared times x cubed. Y times y is y squared. Plus, well then anything times 1 is itself x squared y. Okay? Yep. You distribute it back out and you can check it. Distribute it back out and you can check it. If I put this over here, it's a bit better. Let's see. Nope, made it worse. Okay. Moving on. So for this just listen for a second. It says you may be able to factor expressions with lead coefficients other than 1 in your head or by using guess or check. Again, there's a method called bottoms up. We won't talk about that today. Expressions with lead coefficients other than 1 in the form ax squared plus bx plus c can sometimes be factored by grouping, which is really, really easy. And we'll talk about that. If you struggle with factor expressions in your head or by using guess and check, factoring by grouping is a more structured alternative. Easy, and we'll talk about it. Okay? All right. So really quick, listen up. It says factoring by grouping. Begin by finding 2 numbers d and e whose product is ac and whose sum is b. You write the expression by replacing bx with bx plus ex, ax squared plus cx plus bx plus c. Okay. I'm gonna stop right there. You've got all these variables. Okay. Now, when it says factor by grouping, okay, this is usually generally done when you have like 4 terms. Okay, and you take a GCF out and you have your parentheses, just like what we did. Anytime it says factor by grouping, you're going to have 2 sets of parentheses that are always going to be the same. Okay? Always going to be the same. Now, after I have 2 sets of parentheses that are the same, I can write that and then write what I have left over. really, really easy. Okay? And I'll just do that by showing you examples in just a second. Okay? Alright. Quadratic expression in the form ax squared minus b squared is called a difference of squares. Okay? These are really, really easy. The difference of squares ax squared minus b squared can be written in factored form as ax plus b and then ax minus b. Alright, I'll show you an example of difference of squares. What I write on the board, please write it down. Okay? You need to put difference of squares, and I'll have an example for you. Okay? Difference of squares. Okay. Now, you see difference of squares. What do you think of when you see difference of squares? What does difference mean? Subtraction. Is this a subtraction problem? Okay. It's a subtraction problem. Squares. Okay. And we're not talking about the shape. What do you think when it says difference of squares? Square root. I'm looking for perfect squares. Someone give me an example of some perfect squares. I've heard some. Perfect squares. I heard 4, I heard 9, I heard 25, I heard 36. And why are those perfect squares? Because what times what will give me 4? 2. What times what will give me 9? What times what will give me 25? What times what will give me 36? Okay. Now, whenever you guys see this, difference of squares is always going to be a binomial, 2 terms. Okay? It's always going to be a subtraction problem. Now, first thing I always ask myself when it comes to factoring is what? Is there a what? Is there a what? So I have a GCF. No. Okay? Now it only has 2 terms. This is the same exact thing. My answer is going to have how many parentheses? 2. Let me go ahead and write it. Alright, now in terms of difference of squares, I'm looking for perfect squares. Is x squared a perfect square? Yeah, it is, because x times x gives me x squared. Okay? Well, if it's a perfect square, guess what I can write right here? X and x. Alright, is 81 a perfect square? Yeah. What times what can give me 81? 9. So I'll write 9 here. And 9 here. Now, here's the tricky thing. It's always going to have a minus for it to be difference of squares. That's why it's called difference. Difference means subtraction. Now, my answer, I'm always going to have a minus. And I'm always going to have a plus. That's it. I'm done. If I wanted to check that, what could I do? I'm looking for one thing. If we've got 2 binomials, I'm going to pull it. First out or inner last, right? First out or inner last. That's it, I'm done. Now, I've had the question, can the plus be right here and the minus be over here? It don't matter. It don't matter. Now, I can't have a minus and I can't have a plus and a plus. If you pull that back out and check, you would not get x squared minus 81. That's the difference of squares. That should be pretty easy. Okay? Now, if I wanted to do another one, I might have x squared minus 36. I might have x squared minus 25. Take a second, see if you can't solve those really quick. X squared minus 36, x squared minus 25. Don't have to. First thing I do, does it have a GCF? Nope. It doesn't. Is it a difference of squares? It is. X squared is a perfect square. We just talked about 36 is a perfect square, and we just talked about 25 is a perfect square. The only thing you got to make sure you have when you put in your parentheses is a minus and a plus. It can't be 2 minuses, and it can't be 2 plus. Okay. So looking at that first one, I've got x squared minus 36. What am I going to put in my parentheses? Someone raise your hand and help me out. Tony, help me out. X minus 6. What about this one? X plus 6. Absolutely right. Got a minus and a minus. Perfect squares because it's different. Okay. Square root of 36 is 6. Good to go. If I wanted to check, I could fold that back out. Someone help me out with the second one. Kayla, that's close enough to hand. What goes right in the first one? Yep. X plus 5. That's factor. Awesome. Difference of squares. Easy stuff, right? Okay, now, it says some expressions cannot be factored. These expressions are said to be prime. Well, prime numbers are what? Something that can only be, that can go into it itself and 1. Someone name a prime number. 3, 1, 5, 17, 20, what? Any other 20s? Or no? What else? Anything else? 37? Well, what about 15? What about 25? Not every odd number is a prime number. Good question. Okay. Says although the difference of squares is factorable, the sum of squares is prime. What that means, okay, the sum of squares is prime. So if I'm looking at something, okay, if I told you to solve this one, tell me what you would do. All right, x squared plus 81. What's my answer? Well, you sure? I can't do that. Why? That's not the what. It's not difference. That's not the difference of squares. This is an addition sign. Here's the thing. Pay attention. Eyes up here. Eyes up here. If there's an addition sign right here, you can't do it. Tony, you can't. All right? If it's not a subtraction sign, that's not a difference of squares. You can't do that. There's nothing you can do to factor that out. Not factorable. Okay? Yep, not factorable. Okay, now it says, for example, 3x squared minus 5 squared equals 9x squared minus 25. That's the difference of squares. Okay? Let's see. Now 3x squared plus 5 squared, which would be 9x squared plus 30x plus 25. That's not factorable. That's not the difference of squares. Difference of squares is something that has to be a subtraction problem. Don't get confused when you see x squared plus 81. You can't do it. X squared minus 81, yeah, we just did that. That's the difference of squares. Okay, if there's a plus, an addition sign in there, you can't do it. All right, it's not difference of squares. Okay, common errors that usually happen, forget to consider the signs of A, B, and C. Addition, subtraction. Okay, that's a big common mistake is you don't look at what's in front of the number. Treating a lead coefficient other than 1 as if it were a 1. Okay, meaning, okay, if I just said x squared, someone puts like a, or if there was 2x squared, you just thought of it as x squared. You can't do that. Multiply the terms of an expression given in factor form to solve an equation. Solving an expression that is not part of an equation, confusing the difference of squares with the sum of squares. That's big. If you do not know difference of squares is right, yeah, difference. I go, well, those are both perfect squares. I just run my 2 parentheses. You're done. Okay? You're done. You have to know difference of squares is what you need to do. All right, here we go. Take a second, write the example down. It says solve 8x squared minus 8 equals negative x squared plus 56 by factoring. Okay? First thing, here's a hint. Is that an ax squared plus bx plus c equals 0 form? No, it needs to be in that. Okay? It needs to get there. Take a second, copy it down. Anyone take a guess what the first thing I do is to get it in ax squared plus bx plus c form?
Add
I would subtract x squared from both sides. I like the ones with positive numbers. Because if I subtracted 8x squared from both sides, then I'd have, well, 1 minus 8 is negative 7, right? So I'd have what? Oh, it is negative, you're right. So I add x squared to both sides. Now what do I have? 9x squared. Subtract 56 from both sides. Let's cancel out. So I subtract 56. What is negative 8 minus 56? Use your calculator. That's why you got it. 864, right? All right, look at this. 9x squared minus 64. You notice anything about it? Two terms. Is 9 a perfect square? Is x squared a perfect square? Is 64 a perfect square? Is that a subtraction sign in between them? So what is that? Difference of squares. Okay, so this is easy now. All I've got to do, how do I set my answer up? With how many parentheses? Two. I always want to make sure I drop down my zero, because we do have a zero now. We're going to use the zero product property. Okay? What is the square root of 9? 3, right? It's perfect square. 3. We're going to multiply. What is the square root of x squared? Okay, since I know it's a difference of squares, what are my signs going to be? Minus and plus. Square root of 64. 8. All right, now. Zero product property says I set each parentheses equal to 0. And I solve it. Well, so how do I solve this equation right here? Add 8 to both sides. Those cancel. 3x equals 8. Gotta divide and get x by itself. X equals positive 8 over 3. This one, subtract 8 from both sides, those cancel. 3x equals negative 8. Divide by 3 on both sides. X equals negative 8 over 3. So now I've got my two answers. After you got that work down, I want you to solve. It says solve x squared plus 8x equals 20 by factor. Be the last problem I do today before I give you guys some work. X squared plus 8x equals 20. Okay. You good? We ready to go? All right. Solve x squared plus 8x equals 20. Is that an ax squared plus bh plus c form? Now I need everything on one side of the equal sign. So what do? Add 20. That's 40. Subtract 120. I want to cancel. What I do on one side, I got to do the other. Those cancel out. I've got x squared plus 8x minus 20 equals 0. All right. Is that the difference of squares? No, I've got more than two terms, right? Okay. This has to do with one of the first problems we talked about. Okay? I'm looking at my factors of negative 20. What times what can give me negative 20? Okay? So my first step, now one right here and we'll put a step. What times what can give me 20? 4 and 5, what else? 2 and 10, what else? Don't forget to leave out 120, you never know. Okay. What's my answer always going to have? How many parentheses? I'm going to have an X in both of them. Okay, now, we're going to fill these parentheses up with either 4 and 5, 2 and 10, and 120. Okay? Okay, I know 4 times 5, 2 times 10, 1 times 20 will give me 20. Alright, now I got to figure out which one of these, when I combine them, can give me positive 8. And 4 and 5 combine any way to give me 8. What's 4 plus 5? 9. Okay, what's 4 minus 5? What's 1 plus 20? 21. What's 20 minus 1? So we know those aren't right. Now check this out. I know for a fact 2 and 10 are going to go in there. I can combine them somehow to give me 8, right? Alright, now check this out. That's got to be positive, okay? And I got to multiply them to be negative. One's going to be negative and one's going to be positive, okay? If I can combine 10 and 2 to get positive 8, what would I need to do? What do my signs need to be? Some of you can check that table we put up there. You can copy down. Negative what?
Negative 2.
Negative 2 plus 10. Check this out. What's negative 2 times 10? Negative 20. What's negative 2 plus 10? Positive 8. I'm about to show you guys a smiley face method how you can check. Check this out. Smiley face method. Works every time. Alright, so we've got our original function. We've got x squared plus 8x minus 20, right? Okay, factor it out. We have an x minus 2 and x plus 10. Alright, now this is how we check. Negative 2 times x is what? Negative 2x. What's x times 10? 10x. If I combine them, what's negative 2x plus 10x? 8x, right? Is that the same as my middle term? No, you do not have to draw all the tongue and glasses and all that other stuff, but multiply negative 2 and x, get negative 2x, multiply x and 10, get 10, combine them. If it's the same as our bx term or middle term, you're right. Okay? Alright, now, for homework. Now, I know it's been a week since we've had them out. Those packet 5s I gave you, 5-1 packets, get them out. I do have some bad news for those of you guys that aren't organized, though. If you don't have it, you're going to have to go to my website for me to print you off another one. Or you're going to have to copy. If you don't have it with you on your person right now, you're going to have to get with someone to copy problems now for homework. Okay? Because that's all on you about being organized. I'm not going to continue to print things off if you can't keep track of your own work. Okay? 5-1 packet. We've already done some of it.